Set up your lab station. Begin heating your hot water bath as soon as possible.
Weigh the dry, empty 250 milliliters flask with its foil cover to the nearest 0.0001 gram.
Obtain an unknown liquid and record its identification number.
Add 5 milliliters of the liquid to the dry Erlenmeyer flask. Cover the flask with a foil cover, making sure that the foil cover is tightly crimped around the rim of the flask. Punch a single small hole in the foil cover with a needle or pin.
Heat the water in the beaker to boiling.
Immerse the flask containing the unknown liquid in the boiling water so that most of the flask is covered with the water of the heating bath.
Watch the unknown liquid carefully. The liquid will begin to evaporate rapidly and its liquid volume will decrease.
When it appears that all the unknown liquid has vaporized and the flask is filled with vapor, continue to heat for 1 to 2 more minutes. Then remove the flask from the boiling water bath. Use the clamp on the neck of the flask to protect your hands from the heat.
Set the flask on the lab bench, remove the clamp, and allow the flask to cool to room temperature. Liquid will reappear in the flask as the vapor in the flask cools. While the flask is cooling, measure and record the exact temperature of the boiling water in the beaker, as well as the barometric pressure in the laboratory.
When the flask has cooled completely to room temperature, carefully dry the outside of the flask to remove any droplets of water. Then weigh the flask, foil cover, and condensed vapor to the nearest 0.0001 gram.
Repeat the determination by adding another 5 milliliter sample of the same unknown liquid. Reheat the flask until it is filled with vapor, cool, and reweigh the flask.
The volume of the flask may be approximated by completely filling the flask with water and pouring the water into a 500 milliliters graduated cylinder, reading the water level in the cylinder.
Calculate the molar mass of the liquid. Show all work. We calculated the following values for the molar mass of unknown number 2.
Based on our calculations and the molar masses of the possible unknowns, we concluded that unknown number 2 was acetone.
Zeros at the beginning are never six. Captive zeros are always significant. Beginning is never, the middle is always the end. Yes, dot, no dot, no. Beginning is never, the middle is always the end. Yes, dot, no. Then it comes down to the zeros at the end. You gotta look to the decimal, my friend. If there's a dot there, the zero at the end has significance. If there's no decimal, it's time to say good riddance. Beginning is never, the middle is always the end. Yes, dot, no. Beginning is never, the middle is always the end. Yes, dot, no. Beginning is never, the middle is always the end. Yes, dot, no. Beginning is never, the middle is always the end.
Say hi to the camera, Tyler.
Hi, camera, tell her.